Our topic is NOR gate. We can define NOR gate as output assumes zero state if at least one of the inputs assumes one state. Symbol of the NOR gate is drawn. In this figure, we have two inputs A and B and one output Q. Its Boolean expression is Q is equal to A plus B whole complement. And the truth table is also drawn, in which we have two inputs A and B and one output Q. If both the inputs are 0 state, then output is one state. If A input is 0 state, B input is one state, output is 0 state. If A input is one state, B input is 0 state, then again output is 0 state, and if both the inputs are 1 state, output is 0 state. So this NOR gate can be more than two inputs as shown in the figure, in which we have NOR gate having three inputs A, B, C, and similarly we can write its Boolean expression as Q is equal to A plus B plus C whole complement. This NOR gate is enabled when zero state is given to one of its inputs, and if pulses are given to its other input, then these pulses will pass through the gate because the gate is open. Now we have AND gate. We can define AND gate as output assumes zero state if at least one of the inputs assumes zero state. Symbol of AND gate is shown in the figure, in which we have two inputs A and B and one output Q. Its Boolean expression is Q is equal to A dot B, and its truth table is also shown, in which we have two inputs A and B and one output Q. If both the inputs A and B are 0 state, output is 0 state. If A is 0 state, B input is 1 state, output is 0 state. If A input is 1 state, B input is 0 state, output is 0 state. And if both the inputs are 1 state, then output is 1 state. Note that output is only 1 state if both the inputs are 1 state. Now this AND gate may be of more than two inputs, and the AND gate is made enabled when one state is given to its one input, and if we apply pulses on the other input, then these pulses can pass through the gate because gate is open. In this symbol, we have AND gate of 4 inputs and 1 output, and similarly we can draw its Boolean expression as Q is equal to A dot B dot C dot D, and in this way it is also made enable when 3 inputs are given one state, and the fourth input, if it is used to apply the pulses, then these pulses will pass through the gate. In this slide, we have NAND gate, We can define NAND gate as output assumes one state if at least one of its inputs assume zero state. Symbol of the NAND gate is also shown, in which we have two inputs A and B and one output Q. Its Boolean expression is Q is equal to A dot B whole complement, and in the truth table we have two inputs A and B and one output Q. When input A and B are 0 state, output is 1 state. If A input is 0 state, B input is 1 state, output is 1 state. If A input is 1 state, B input is 0 state, output is 1 state. And if both the inputs A and B are 1 state, then output is 0 state. Now note that output is 0 state only if all the inputs are 1 state. This NAND gate can also be of more than two inputs, and similarly we can write its Boolean expression. NAND gate may also be of more than two inputs. As shown in the figure, we have three input NAND gate and its Boolean expression is Q is equal to A dot B dot C whole complement.